All right, Econ 200, let's go over the Chapter 8 problems. This is probably going to be a rather long video because there were several problems that people suggested that they needed help with, and I want to make sure that I can get through them because we have the midterm exam coming up on Wednesday of next week. So let's jump right into it. First problem I'm going to talk about is from Facts and Tools, and it's problem number 4, and it reads as follows. If a government decides to make health insurance affordable by requiring all health insurance companies to cut their prices by 30%, what will probably happen to the number of people covered by health insurance? All right. So to illustrate what's going to happen, I've got a supply and demand curve here. We've got an equilibrium price, and you can imagine this is the market for health insurance. And that equilibrium price is the price that the government has deemed to be too high. So when the government decides that all insurance premiums must drop by 30%, what they're doing is they are putting a price ceiling on this market that's at some lower level, call it P bar. Now the point of the policy is to lower the price so that more people can afford to buy these premiums. And in fact, if you lower the price, the quantity demanded will increase, right? You're going to have these extra buyers who wouldn't be willing to pay the old premium, but now that you've cut the price for them, they would be willing to purchase a premium. However, it's not just up to the buyers, it's also up to the sellers. And when you cut that price by 30%, you move down along the supply curve and you get a lower quantity supplied. Okay, so at this lower quantity supplied, that's the number of insurance policies that the companies are actually going to be willing to offer. And so the quantity of consumers who receive a policy is not going to be this larger number QD. It's actually going to be this lower number QS, and it'll only end up being these buyers on the demand curve that we would expect to purchase a policy. Okay, so the answer is, if the government required the companies to cut their prices by 30%, what would probably happen to the number of people covered by health insurance is that it would fall. It would be reduced. Okay, so that is problem 4. Let's move on to problem 9 in Facts and Tools. And problem 9 is probably the most complicated that I'm going to go over, or at least part of it is. The part B of problem 9 is a little complicated to think about. So let's go through this. I've got part A and part B here. Let's just focus on the left-hand side of this sheet of paper for the moment. So problem 9, part A. Consider figure 8.8. So that's referring to a figure in chapter 8 of the textbook, and it looks basically like the graphs that I have here. So this is a market for rental housing. This steep blue curve is the short run supply curve, so I'm calling that SRS. This flatter red curve is the long run supply curve. I'm calling that LRS for the long run supply. And then the demand curve is given by this downward sloping blue curve, which I'm calling D for demand. And the government has imposed a price control, a rent control, that is holding the rent below the market rate. Okay, so let's see. In a price-controlled market like this one, when will consumer surplus be larger, in the short run or in the long run? All right. So first of all, let's just take a look at kind of the dynamics of what's happening when you impose this price control. In the short run, we look at quantity supplied can be found along the short run supply curve here. Okay, so in the short run, where this price P bar hits that supply curve, gives us the quantity supplied, QSR, the quantity in the short run that the sellers will supply. Buyers want to buy more units than that. At this low price, where it hits the demand curve, that gives us the quantity demanded, QD. So we're going to start with a shortage in the short run. Although notice that even though there's a shortage, the buyers who do purchase units are going to get to purchase them or rent them at a lower price than they did before. In the long run, over a longer number of weeks, months, years, this short run supply curve is no longer the one that tells us about how many units sellers will offer at a given price. In the long run, we need to move to this red curve. Once we're in the long run, the quantity supplied is going to be even less than it was before. Okay, and so we'll have this quantity supplied, QLR, the quantity in the long run. So over time, the shortage is going to become more severe. At first it's this big, over time it becomes this big. And so intuitively, you should have an intuition right off the bat that since the shortage is getting worse over time, consumer surplus is going to get smaller over time. And I'll show you why that, or I'll show you graphically how that works out here. Okay, so in the short run, you've got this quantity QSR, and remember that consumer surplus is everything below the demand curve and above the price for all the units that are actually traded. Okay, so we can fill in this area right here, and I'm going to shade this. To make it a little bit more clear. So, as kind of a key on the right-hand side, we've got the consumer surplus in the short run is given by this shaded area right here. Okay. Now, in the long run, what's going to happen? Well, in the long run, producers are going to cut back on their output. They're going to cut it from QSR down to QLR. And so you're not going to get all of this surplus. Well, let me put the... Consumers are no longer going to get this area of surplus here because they'll only be consuming that number of units. So in the long run, the consumers end up with just this area here, and I'll shade that in like so. Consumer surplus in the long run. So you can see the consumers are helped out more in the short run than they are in the long run by a rent control law like the one that's discussed or illustrated in figure 8.8. Okay, so that is part A. Now that's not particularly difficult. Part B is the one that gets a little bit more complicated because they start asking about losses. Are the losses to the producers going to be greater in the short run or in the long run? So part B, the wording of the problem is as follows. In this market, supply is more elastic or more flexible in the long run. In other words, in the longer term, landlords and home builders can find something else to do for a living. In light of this, and in light of the geometry of producer surplus in this figure, do rent controls hurt landlords and home builders more in the short run or in the long run? Okay, well, your intuition here should kind of go as follows. In the short run, the suppliers don't have as many options of what to do. If you're a landlord and you've got a house and rent control is imposed, in the short run, it's going to be difficult for you to do anything about it. But over time, you can get out of that business. You can sell your house off so that you're not a landlord anymore. You just take the cash out of it by selling to somebody else. If you're a home builder, same deal. Initially, you might have difficulty finding another line of work, but over time you can find something else to do with your resources instead. Over the long term, when you have more options, your supply curve is going to be more elastic. And so we would expect that most of the economic bite here, or more of it, is going to happen early to the suppliers than it will over the long term. Over the long term, they should be able to adjust. So let's take a look at how that would work out. So in the short run, the amount of producer surplus that would exist in equilibrium is everything below the equilibrium price and above the short run supply curve, right, for every unit that they actually rent. So it would be this area that I've marked in green. Okay. Now, once you impose the price control, what happens? Well, you're going to eliminate this area that's above the new price P bar. so that now the producer surplus is going to be this smaller area here. Okay. Well, how much have they lost? They've lost all of this area that is between the equilibrium price and the new price controlled price. And so in the short run, the loss to the sellers can be shown in this red area here. Okay. So let's put that up here. Lost producer surplus in the short run, that area. Okay, what about in the long run? Well, in the long run, their producer surplus would not include the area below this long run supply curve and above this short run supply curve. In the long run, their producer surplus would be this triangle right here. Okay? But since the price control has been imposed, they don't get this entire triangle. Instead, they only end up with this smaller triangle below the price controlled price and above the supply curve. So what is the loss to them in the long run? Well, it's going to be the area of this shape right here, which I will put in hash marks. That is the lost producer surplus in the long run. And as you can see, this is a smaller area of lost surplus than that is. And so the rent control is going to hurt the landlords and the home builders more in the short run than it will in the long run. All right, so that is problem 9. Now we're going to move on to the problems in the section on thinking and problem solving. And the first problem I'm going to go over is problem number 4. So let me turn to that in the textbook. All right, problem 4. Let's count the value of lost gains from trade in a regulated market. The government decides it wants to make bicycles more affordable, so it passes a law requiring that all one-speed bicycles sell for $30, well below the market price. Use the following data to calculate the lost gains from trade, just as in figure 8.3. Supply and demand curves are straight lines. The fact that they're straight lines, by the way, is important because it tells us we can do these calculations with simple geometry instead of worrying about integral calculus. All right, so I have reproduced the graph that they give you in the textbook, and what you can see is in equilibrium there would be 200 units that trade. We're not given the price, but as we'll see in part C, it doesn't really matter. And then there's a price control of $30. At that price controlled price at 30, that hits the supply curve at 100 units. So now there's only going to be 100 units that sellers are willing to sell. Take that 100 units, plug it into the demand curve, and you find that this buyer right here would be willing to pay $80 for that 100th unit. So all of these buyers along the demand curve up to this point, they'd all be willing to pay $80 or more to get a unit. Okay, so that kind of lays out the numbers that we're looking at. Part A, what is the total value of wasted time in the price controlled market? All right, well, remember that when there's a price control, one of the ways that buyers might compete with each other is by waiting in line and spending time searching for the good. And if that happens, then they're basically paying two prices for the good. They're paying the dollar price, which is right here, $30 per unit, but they're also paying a time price, which is the value of the time that they spend in line. And you can see from this graph that the most that these buyers would be willing to spend of their time waiting in line is $50 a unit, the difference between their willingness to pay and the price they would actually have to pay. Okay, so there's $50 a unit in wasted time, and there are 100 units that are being traded. And so the value of wasted time is going to be the area of this rectangle right here. The height of that rectangle is 80 minus 30. It's the difference between willingness to pay and the price that the sellers can charge. And the length of this rectangle is 100 units. So simplifying, 80 minus 30 is 50 times 100, and that tells us that the total value of wasted time will be 50 times 100, or $5,000. That's part A. Part B, what is the value of the lost gains from trade? The lost gains from trade, also known as the deadweight loss in this market, that's going to be the loss on these units that are no longer trading. So from unit 100 to 200, it's the case that buyers would be willing to pay more than it costs the sellers to produce those units, but the sellers are not willing to produce them because the price they can sell them at is too low. They'd lose money on those transactions. And so the deadweight loss is given by this triangle right here. And the area of this triangle has a height that is equal to the difference between the maximum willingness to pay and the price control. Just like the wasted time rectangle. Its length is 100 units, which we get by taking the number of units that would be traded in equilibrium and subtracting out the number of units that are actually trading. And then we divide this by 2. What does that give us? Well, this is 50, that's 100. So we've got 50 times 100 divided by 2. We already know 50 times 100 is 5,000. Divide that by 2, and we've got $2,500 in lost gains from trade. And part C. Part C says, note that we haven't given you the original market price of simple bicycles. Why don't you need to know it? And the hint is, the answer is a mix of geometry and economics. All right, so the geometry part is, we just need to calculate the area of these two geometric shapes, this rectangle and that triangle. And the economics is, the equilibrium price doesn't really come into the area of either of those two shapes. For the losses from wasted time, you just need to know the difference between what this 100th buyer would be willing to pay and the price that the seller is actually willing to sell at. You need to know that difference, and you need to know how many units will trade in this market, and that will give you the value of the wasted time. For the deadweight loss, or the loss from foregone trades, all you need to know is, once again, the difference between willingness to pay on that 100th unit and the price on the 100th unit to give you the height of that rectangle. And then you just need to know how many transactions are going to be lost from the equilibrium. What's the difference between the number of transactions we would have without the price control and the number of transactions we have with the price control? So that is problem 4. Now let's move on to, I believe, problem 6. And I've got problems 6 and 10 on the same sheet of paper here to save space. So once again, we're going to focus on the left-hand side of the page first. Problem 6. I'm going to spare you some of the front material and skip to the chase. Consider the following claim. Price-controlled markets tend to create black markets. Let's illustrate with the following figure. If there's a price ceiling in the market for cancer medication of $50 per pill, what is the widest price range within which you can definitely find both a buyer and a seller who would be willing to illegally exchange a pill for money? There's only one correct answer. Okay, so we have our market for cancer pills, right? Well, cancer curing pills. And the equilibrium price would be $100, but suppose that you impose a price control of $50. and you would end up selling 100 units at that price. What is the widest range? Is that right? What's the widest price range within which you can definitely find both a buyer and a seller? Okay, so first of all, let's consider, over here. I don't know, they don't give us the numbers here, but maybe that's $2 and that's $200. Okay, so it would be possible there is a price range between, let's say, $2 and $200, where you could find one seller who's willing to trade and one buyer who's willing to buy. But at those, but that price range leaves out all of these other buyers down the demand curve and all of these other sellers up the supply curve. And so the point here at 100 units, this tells you at a price of $50, all of these sellers would be willing to sell. And at a price of $160, all of these buyers would be willing to buy. Okay? And so you could definitely find a willing buyer and a willing seller as long as the price falls somewhere along this line segment right here, somewhere within the range of $50 and $160. Okay? That brings us to problem 10. Again, I'm going to save you from the most of the front material and just kind of skip to the chase. The lead up to the question, which is in two parts, part A and B. The lead up to the question talks about how in the 1990s in Santa Monica, right here in good old California, ATM fees were banned. Out of network ATM fees, right? So you would have these banks where if you were a member of the bank, if you were a customer of the bank and you had an account with them, you could use their ATMs for free. But if you weren't a customer of the bank, well, they'd still let you use their ATMs, but they would charge you $2 per transaction. And the city of Santa Monica outlawed that, okay, which effectively is like making a binding price control that's below the equilibrium. And so this graph is showing the market for ATM out-of-network fees. The fee is the price, and the quantity of transactions, out-of-network transactions, would be this quantity Q on the x-axis. And part A asks you the following. In the figure, indicate the new price per out-of-network ATM transaction after the fee ban, and also clearly label the shortage. Well, once you have a fee ban, no price above zero is legal, right? So the new price is here at $0 per transaction. And if you draw a line from that transaction from that price along the x-axis, wherever it hits the supply curve, that shows you the quantity supplied, which, by the way, is going to be equal to 0. And on the demand curve, you've got the quantity demanded. And the difference between those two is the shortage. Okay, so that's the labeling of the shortage. That's part A. Part B says the following. Calculate the exact amount of producer and consumer surplus in the out-of-network ATM market in Santa Monica after the ban. How large is producer surplus? How large is consumer surplus? Okay, well, remember that consumer surplus is this area right here in equilibrium. It's everything below the demand curve and above the price that the buyers pay. And the producer surplus, the area is the distance between the y-intercept of the demand curve and the price that the buyers have to pay. You multiply that by the quantity of units that they purchase, you divide by 2. Well, we can see that the quantity of units they're going to purchase is equal to 0. So you multiply this difference by 0, the whole numerator is going to be 0, so producer surplus will also be 0. For consumer surplus in equilibrium, it would be this area. And recall that the producer surplus formula is you take the price that they are able to charge, you subtract out the y-intercept of the supply curve, and you multiply that by the quantity of units that they sell, divide by 2. For the producers, just like for the consumers, the quantity is going to be equal to 0. But also it turns out the price is equal to 0 and the y-intercept of the supply curve is equal to 0. So everything in the numerator is a 0. So producer surplus is going to be 0, just the same as consumer surplus. And I can see right here that I mislabeled that. If I was in class, I would have expected you to throw something at me and inform me right away. But you're not here to do that, so I have to fend for myself. Consumer surplus follows that formula. That's problem 10, and that brings us to the final problem that I'm going to talk about from chapter 8. That's problem number 16. And problem 16 reads as follows. In the market depicted in the figure, there is either a price ceiling or a price floor. Surprisingly, it doesn't matter which one it is. Whether it's an $80 price floor or a $30 price ceiling, the chart looks the same. In the chart, there's a rectangle and a triangle. One represents the value lost from the deals that don't get made, and one represents the value lost from the deals that do get made. Which is which? Okay. So first of all, let's talk about why it doesn't matter whether we have a price ceiling or price floor here. If it's a price ceiling, then at $30, the most that the most units that the sellers will sell is here at 100 units. Okay. If you take that 100 units and plug it into the demand curve, you'll find the willingness to pay of that 100th seller. So that's how you'd get 30 and 80. On the other hand, if it is a price floor of $80, now it is the buyers who would purchase no more than 100 units. And so if you take those 100 units, plug it into the supply curve, you'll find that the willingness to accept for that 100th seller is $30. So either way, you're going to get exactly the same graph. Okay. Now they say one of these two areas represents the value of the loss from deals that don't get made. The other is from deals that do get made. Let's start with don't get made first, because that's going to be the same logic in either case. In either case, whether you hold the price at 80 up to 80 or you hold the price down to 30, there would have been 200 trades in equilibrium. There's now only 100 trades. And so this area B represents the deadweight loss. It represents those transactions where the buyers would have been willing to pay more than it cost the sellers. So these are, there are gains from trade to be had here. But because of the price control, whichever one it is, those trades don't happen. And so B is the loss from deals that don't get made. Okay? That leaves us, by process of elimination, A must be the loss from the deals that do get made. How would we have a loss from that? Well, we already talked in the case of price ceilings with an earlier problem, we talked about how that could be the case. If you have long lines and search costs, the buyers compete with each other by just waiting around and wasting their time, then you get this loss of $50 in time value on every unit that's traded, and that's multiplied by the 100 units that do trade. And so in that case, A would represent the loss from deals that do get made in the sense of it's the value of the lost time on those transactions. Okay. What about if this was a price floor? Well, if it's a price floor, remember from the lecture on price floors that if you hold the price above equilibrium, then the sellers have an incentive to basically have wasted quality. They produce a good where the quality, let me back up. The cost of the quality upgrades exceeds the value of those quality upgrades to the consumer. And in the limit, they would be willing to spend all of this area A to compete with each other in extra costs that exceed the value to the consumer. Okay, so in either case, whether this is wasted time or this is the excess cost of quality upgrades, A represents the value lost from the deals that do get made. Okay, so that is it for the homework for Chapter 8. Please be sure to fill out the questionnaire for Chapter 9 so that I can post a video on that early in the weekend. Thanks a lot, guys, and as always, be flexible, communicate, and stay awesome.